Assalamu alaikum everyone. Today we are going to solve May-June 2024 429709 mechanics paper, and without any wasting any minute, let's jump on to the first question. Okay, question number 1, it says a cyclist and a bicycle has a total mass of 72 kgs. The cyclist drives along a horizontal road against a total resistance of 28 Newton. Let's visualize it first. It says that there is a horizontal road, and on the horizontal road there is a cyclist, and he says that the cyclist is moving. For example, if he is moving in this direction, so this will be the driving force. The opposite direction is going to be the resistive force, which is given as 28 Newton. Find the total work done by the cyclist to increase his speed from 8 meter per second to 16 meter per second while traveling a distance of 100 meters. So in the start the speed was 8 meter per second, but in the end the speed was 16 meter per second. So we basically need to find out the total work done by the cyclist. So since the question is related to energy, what we are gonna do is, the question is related to energy, so we are gonna do energy before. Total energy sum is always the same, so energy before and energy afterwards, they are both going to be same. So energy before is potential energy, which is 0, and the potential energy afterwards is also 0 because there is no change in the height. The kinetic energy before, it's half m, mass is 72 kg, and the speed by which it is moving in the start is 8, so 8 square, so 0.5 into 72 into 64, which makes it 2304 joules. Similarly, kinetic energy afterwards, when the speed has increased to 16, the kinetic energy will be half into 72 into 16 square. So it will be 0.5 into 72 into 16 square, which is 9216. And after that there comes work done by the driving force. So work done by the driving force is the one that we need to calculate. So let me mark it as x, and the work done against friction is going to be the work done in after. So work done against friction is frictional force multiplied by the distance covered. So frictional force is 20, resistive force is 28, and the distance covered is 100 in the same direction, which makes it 2800 joules. So energy before will be equal to energy after. We are gonna sum them up of the left side, which will be 0 plus 2304 plus x, and it will be equal to 0 plus 9216 plus 2800. So from here the value of x can be calculated, 9216 plus 2800, which will make it 12016 minus 2304. So the work done will be 9712 joules. I hope the question is clear. Let's move to the next question. Question number 2. Question number 2 says that the particle P moves in a straight line at time t seconds after leaving O. On the line P has the velocity v meter per second, where v has the expression of 44t minus 60 square minus 36. This is an equation for v. You need to find the set of values of t for which the acceleration of the particle is positive. So this is the keyword here. The acceleration has to be positive, which means the value of a has to be greater than 0. The equation that is given to us above is related to velocity, and we know that if we find out the derivative of the velocity equation, we get the acceleration. So basically what is he saying is that dy by dt has to be greater than 0. So let's find out the dy by dt. It will be 44 minus 12t greater than 0. So if I simplify, it will be 44 greater than 12t, and it will be 12t less than 44, because I have changed the sides. So 44 divided by 12, it will be, the value for t will be less than 11 by 3 seconds. Okay. Part B for the second question says that find the two values of t at which p returns to O. P returns to O. It means that the particle p is starting from this O point. It is covering some distance, then it is coming back to the point O. He is going in the opposite direction, then he is coming again back to O. Okay, so the time will be 0 in the start, then there will be some second time, and then there will be another time when he is going to return back to the point O, the initial point, the start point. So we know that we have an equation for velocity, and if we take the integration of this, we will find out the equation for the displacement. So S will be equal to 44t minus 60 square minus 36t dt. If I found the derivative, it will be 44t square divided by 2 minus 12t cube divided by 3 minus 36t plus c equals to S. Let me simplify. 22 4. So expression for S will be 22t square minus 4t cube minus 36t plus c. Now I'm sure you must agree with me on this, that the displacement will be 0 when the time is 0. Displacement at the start of the journey will be 0, and the time at the start of the journey will also be 0. So we can easily calculate the value for c, which is unknown. So 0 is equals to 22 times 0 minus 4 times 0 to the power of 3, 36 times 0 plus c. The value of c is 0. So the expression for displacement is S equals to 22t square minus 4t cube minus 36t. This is an expression for the displacement. Now we need to find out the time when the object P is coming back to the point O. So coming back to the point O means that the displacement has to be 0. So let's substitute the value of S as 0. We will substitute the value of S as 0, and we are basically interested in finding the time when he is returning to that specific point. So it will be 0 equal 22t square minus 4t cube minus 36t. We can see that t is common. In fact, 2t is common. It will give us 11t minus 2t square minus 18, and it will be equal to 0. Now from here we can already figure out that one value of the time when he will be at the displacement 0 at O point, it will be 0 seconds. The other one will be minus 2t square plus 11t minus 18 equal to 0. So minus 2, 11 minus 18. So here there is a there is some, okay, so it was this is 6, this is not 12, this is 6. So if I cut it is 2, this is 2, 2, this is 2, it is 2 here. So when I have taken 2 out, I will be just left with minus t square. So it is minus 1 plus 11 minus 18. Okay, so the first value of time is 9 seconds and the other value of time is 2 seconds. So he is going to return back to the point O when the time is 2 seconds and the time is 9 seconds. Let's move to the next question, question number 3. For coplanar forces of magnitude P Newton, 10 Newton, 16 Newton and 2 Newton act at a point in the direction shown in the diagram. It is given that the forces are in equilibrium. Forces are equilibrium means that the upward forces and the downward forces will be equal to 0 and the right and the left forces will also be equal to 0, or you can say that the sum of the horizontal components will be 0 and the sum of the vertical components will be 0. So let's first resolve the forces which are not either parallel or perpendicular to the plane or to the point of observation. This is the point of observation. So let me first resolve this one. This is going to be the horizontal component, which will be 10 cos 25. This will be the vertical component, 10 sin 30. Similarly, let me resolve this. This is going to be 16 cos theta. It will be 16 sin theta, and if I resolve this one, this will be 2 cos 40 and this will be 2 sin 40. Now he says that the object is in equilibrium, so it means that the upward forces will be equal to the downward forces and the forces on the right will be equal to the forces on the left. So let's simplify. Right forces will be equal to the left forces. So right forces, how many right forces do I have? Let me write. There is just one right component, so which is 10 cos 25, which will be equal to the sum of the components to the left, which is 2 cos 40 plus 16 sin theta. There is just one unknown in this equation, that is the theta. We can simplify to find out the theta value from here. That will be 10 cos 25 minus 2 cos 40 equals 16 sin theta. So sin theta will be equal to 10 cos 25 2 cos 40 and it will be divided by 16. So it's 10 cos 25 minus 2 cos 40 divided by 16. It's Sine theta is 0.47068. Sine inverse, it will give us theta as 28.1 degrees. Now we will solve it for up equals to down. Up will be equals to down. Let me mark the, up equals to down. And how many upward forces do I have? P, and that's it. So P will be equal to the downward forces, which is 2 sine 40 plus 10 sine 30 plus 16 cos theta. 16 cos, the theta value is already known to us, and the theta value is theta is 28.1. so let's substitute it here. 28.1. we just need to put simplify. It will be 2 sine 40 plus 10 sine 30 plus 16 cos 28.1, and the value for P will be it will be 2 sine 40 plus 10 sine 30 10 sine 25, 10 sine 25. let me fix this. This is 10 sine 25. Answer is 19.6 Newton. This is the value for P. Okay, let's move to the next question. Question number 4. Question number 4 says that a car has a mass of 1400 kg. When the speed of the car is v meter per second, the magnitude of the resistance of the motion is this. So when the speed of the car is v meter per second, the resistance to the motion is this. The car moves at a constant speed of, now he's in the A part, he says that the speed of the car is this. Constant speed means that the acceleration portion will be 0. Up an inclined plane at an angle of alpha, so it means that sine alpha is basically 0.12, and which is 3 by 25. At this magnitude, at this speed, the magnitude of resistance to the motion is 480. So it means that we need to put the 480. We need to put the resistance equals to k square v, kv square. The value of v is given to you for the specific resistance, that is 24 equals to 480. So 480 divided by 24 square, which is the value of k is 5 divided by 6. Okay, next part. Let's move to the next part. Next part says the second part says that find the power of the car's engine. Okay, so for doing that, let me visualize that first. Let me visualize the car is moving on the inclined plane. This is the inclined plane. This is the alpha that they are talking about. There must be the weight of the car. The mass is 1400, so the weight is 14,000. So there will be one component acting in the horizontal and one in the vertical. So this is the alpha. This will be 14,000 cos alpha, and this will be 14,000 sin alpha. The value of r, is it a rough surface? There is nothing as mentioned. Rough, yes, it's a resistance, so it's a rough surface. So there is r, and the object is moving the constant speed up a hill. So since the object is moving up the hill, so this will be the direction of the driving force, and this will be the direction of the resistance, and the resistance value is known to us, that is 480. So we know that when the object is in motion, we use forward minus backward is equals to MA. The forward in this case is the driving force minus the backward. There are two backward components. One is the resistive force, which is 480, and the other is 14,000 sin alpha, and it will be equals to mass times the acceleration is 0 because it is moving at a constant speed. So driving force can be calculated from here, which will be equal to 480 plus 14,000 into sin alpha is 3/25. So 14,000 into 3 divided by 25 plus 480, the driving force will be 2160 Newton. So using the driving force, we can find out the power of the engine. Power of the engine is equals to driving force multiplied by the speed. The driving force is 2160, and the speed by which it is moving is 24 meter per second. So multiply by 24, which gives us the power as 51840 watts. This is the power. Now let's move to the B part. The B part says that the car now moves at a constant speed on a straight level road. So it means that the car is now moving on the horizontal road. Let me make the car on the horizontal road. Now the car is moving in the horizontal road. So this is the driving force now, and the resistance is going to be in this direction. Okay. Given that its engine is working at 54,000 watts, so the power is given to us, the power is given, we need to find out the speed. So the power is given to us, we can find out the driving force first. So driving force is equals to power divided by the speed. The power is 54,000 divided by, we don't know the speed by which the car is moving, but he says that okay, but the resistance to the motion is known, which is kV square. So we will apply forward minus backward again. The forward force is going to be the driving force, the backward force is going to be friction resistive force, and mass times the acceleration will be 0 because the object is moving at constant speed. So a driving force will be equal to the resistive force. Let's put the values in here. 54,000 divided by V, it will be equal to the resistive force, which is kV square. K is 5 by 6, so 5 by 6 V square. So 54,000 into 6 divided by 5, which is 64,800, and that's the value of V power 3. So if we take cube root on both sides, the value of the speed is 40.2 meter per second. This is the speed. Okay, let's move to the next question, question number 5. Question number 5 says that a particle of mass 0.8 kg lies on a rough plane which is inclined at an angle of 28 degrees to the horizontal. The particle is kept in equilibrium by a force of magnitude T Newton. So T Newton is basically holding the holding the particle so that it does not move. This force acts at an angle of 35 degrees above a line of greatest slope of the plane. The coefficient of friction between the plane and the particle is 0.2, which means that the frictional force component is given to us, that is 0.2. Find the least and the greatest possible values of T. Now there are basically two cases that we need to do. So let's do case number 1. Okay, so for case number 1, let's find out for the greatest value of T. Particle is about to move up the plane, so friction or the resistive force is acting down. It is acting down the plane. So let's first of all resolve it all. This is the weight, which is going to be 8 Newton. We will resolve the weight in both the directions, the horizontal component and the vertical component. 28 degrees, which will be 8 cos 28, and this will be 8 sin 28. Similarly, we will resolve this one as well, and it will be T cos 35, and this will be T sin 35, and this will be the direction of the resistance, and that is normal reaction force, that is R. Now for the greatest value of T, what we will do is, since the object is in equilibrium, so we will put the up equals to down and the right equals to left. So up equals to down. So for how many upward component do you see? There are two upward component, which is R and T sin 35. So R plus T sin 35. And how many downwards component do I see? There is just one down component, which is 8 cos 28. 8 cos 28, yes. So we can find the value of R from here. 8 cos 28 minus T sin 35. This is the component of R. Now we can do right equals left, because the object is in equilibrium. So the right components are that is T cos 35, and the left component is going to be the friction as well, mu R, because since the object is about to move up, friction is acting down. So we will write T cos 35, T cos 35, it will be equal to mu R plus 8 sin 28. 8 sin 28. We are already aware for the value of R, which is value of mu is 0.2. bracket, the value of R is written here, 8 cos 28 minus T sin 35 plus the remaining, which is 8 sin 28. Let's do the expansion. Cos 35 is 0.81915 T, 0.2 into 8 into cos 28, which is 1.41271 minus 0.2 into sine 35, which is 0.11471 t plus 8 sine 28, which is 3.7557. Now let's collect the t terms to one side, which is 0.81915 plus 0.11471, that makes it 0.93386 t, and it is equals to 1.41271 plus 3.7557, which is 5.16841 divided by 0.93386. The value of the greatest value of t will be 5.53 Newton. Similarly, this was all case 1, and usually this case is of this question type of question is usually of 7 and above marks, which is a good score in mechanics. Let's move on to case number 2. Case number 2 is where we need to find the minimum value of t, which is holding the object in equilibrium position. So for that, for the lowest value of t, for the lowest value of t, particle is about to move down the plane, so friction will acting upwards. Now let's solve the entire whole scenario, but this time the friction is not going to be in this direction, but the friction is going to be in this direction. So let's do it. Up and up equals to down is not going to change at all, because there is no component being changed in that scenario. There is no change in the value of the vertical component, so upwards and downward forces are going to be the same. Let's do it for the right and left. That's a bit changed. Right will be equals to left. Why is that changed? Because there is change in the direction of the frictional component. So that will be equal to, the right forces are 8, the forces to the left is 8 sine 28, and that's it. The forces on the left is 8 sine 28, and the forces to the right, there are mu r and t cos 35. So it's t cos 35 plus mu r. So it's 8 sine 28 plus, which will be equal to the value of t cos 35 plus mu is 0.2. The value of r is written over here, which is 8 cos 28 minus t sine 35. We'll simplify it. So 8 sine 28 is 3.7557. Cos 35 is 0.81915 t plus 0.2 into 8 into cos 28, which is 1.41271 minus 0.2 into sine 35, which is 0.11471 t. We'll collect the like terms on one side, so 3.7557 minus 1.41271, which is 2.34299 equals 0.81915.11471, which is 0.70444 t. So 2.34299 divided by this, the value of t is 3.33 Newton. This is the least value of tension which can hold the object in equilibrium. Let's move to the next question. Question number 6. Question number 6 says that three particles A, B and C of masses 5 kg, 1 kg and 2 kg respectively lies at rest in that order on a straight smooth horizontal track x, y, z. So x initially A is at x, B is at y and C is at z. Particle A is projected towards B with a speed of 6 meters per second, and at the same instant C is projected towards B with a speed of v meters per second. In the subsequent motion, A collides and coalesces. Coalesces means that they combine together with particle and coalesces with B to form the particle D. The particle D then collides with and coalesces with C to form the particle E, and E moves towards Z. Okay, let's visualize it a little. It says that it is on a horizontal track. So on a horizontal track there is A and there is B and there is a particle C. The particle A is on X, B is on Y and C is on Z. A is projected towards the particle B with the speed of 6 meters per second, and when this happens, in this collides with B, and at the same instant particle C is projected towards this side, and the speed of this particle is v meter per second. Now when A and B, A plus B combine, they make particle D, and then when particle D is there, and particle D when combines with particle C, it makes the particle E. This is the whole scenario. What is he asking in the question? He says that show that after the second collision, the first collision is between A and B, the second collision is between D and C. The particle E is moving with a speed of 15 minus v over 4. Okay, so let's talk about the momentum of the particle A and B. Let's talk about A and B first. So for A and B, the momentum before and the momentum after the collision are both going to be the same. So a momentum before collision, let's find out the momentum for this is 5, this is 1 and this is 2. Okay, the momentum before is going to be 5 times initial speed of the particle A is 6. The particle B is having the mass 1 but the speed is 0 because it is at rest, and after that, when it is moved after the collision, the object A and B, they coalesces, they join together. So the mass is going to be the total mass, which is going to be 6, and we are not aware of the speed by which it is moving. So let's calculate that speed as x. Let's find that speed as x. So that speed, let's calculate that speed, and that is 30 is equals to 6x, and the value of x will be 5 meter per second. So this is the speed with which the particle D is moving. So this is the speed of the particle d. This is the speed of the particle d. Now we know that now let's talk about the second collision, and the second collision is between the particle d and c. So c and d, so their momentum is also going to be conserved, momentum before and momentum after. The momentum before is the particle d is having a mass of the 6 kg, because that is the collision of the, or the combined effect of A and B. So it is 6, and the velocity by which it is moving is 5, plus the object, the other object is moving with the speed of is having a mass of 2, the C particle, but it is moving in the opposite direction, so it is going to be minus v. And the momentum afterwards, because they combine together, so the combined together mass is going to be how much? The mass combined together is going to be 6 plus 2, 8. So the mass is going to be 8, but the velocity is the one that we need to calculate. So if I simplify, it will be 30 minus 2v is equals to 8ve. If I make ve the subject, it will be ve will be equal to 30 minus 2v divided by 8. For 2 is common, so ve will be 2 bracket 15 minus v divided by 8. So this can be simplified, and that is the 15 minus v divided by 4 is the one that we were supposed to show, that the speed of the particle v after this e after the second collision. Let's move to the next part. The total mass of the kinetic energy of the system due to the two collisions is 63 joules. So the total loss of the kinetic energy. So the total loss of the kinetic energy is 63 joules. So let's find out the total kinetic energy at the start, and let's find out the kinetic energy at the end. And the difference of both the kinetic energies is given to us as 63. So let's find out the kinetic energy initial. So kinetic energy initial is half m. The mass of the particle A is 5, and the speed by which the particle A is moving is 6. So half mv square, plus what about the particle C, which is moving with the speed of v? So half m is 2 and the speed is v square. So it will be 5 times 36 divided by 2, which is 90, plus they will simplify v square. This is the kinetic energy at the start. Now let's find out the kinetic energy at the end, final kinetic energy final, which will again be half the kinetic energy of the particle. Together it's going to be 8, because the particle E is having a mass total of 8, and the velocity is how much? 30 minus 2v. No, it's not 30 minus 2v, it's 15 minus v divided by 4 whole square. Plus, is there any other particle? When in the end there is no other particle, so that is the total kinetic energy at the end. So they can be simplified. It's 4. So 4 bracket, if I expand it, it is going to be 15 square 225 plus v square minus 30 v divided by 16. So if I simplify, it will be a 4. And we know that the kinetic energy final minus kinetic energy initial, their difference is given to us as 63. This is the where the loss of kinetic energy is going. So let's simplify kinetic energy final initial is the one which is going to be more, no? Because that's the loss. So it's going to be initial minus the final. So initial kinetic energy is 90 plus v square minus 225 plus v square minus 30v divided by 4, and it will be equal to 63. Now if I simplify, it will be 90 plus v, no, let's simplify altogether. So 90 times 4, which is 360 plus 4v square, 225 minus v square plus 30v is equals to 63 into 4, which is 252. So it will be 3v square plus 30v and 360 minus 225 minus 252, which is 117, and it will be equal to 0. It says 330 minus 117. The value of speed is 3 meter per second, and the other is minus 13, and that is the one that we were supposed to show. Or you can say that v is positive, or you can say that c could be moving away from b. Okay, that's it. Part C. Part C says that it is given that the distance xy is 36 meters and the distance yz is 98 meters. So the distance xy is 38 meters, this is 38, and this distance is 98 meters. And what is he asking from us? Find the time between the two collisions. So basically he says that SXY is 36 meters and XYZ is 98 meters. So let's find out the collision of AB. First, let's talk about collision A and B first, and let's calculate the time. The distance over speed. The distance is 36 divided by the speed by which the object A is moving is 6, so it is going to take 6 seconds. In these 6 seconds, how far does C traveled from the Z point. So let's talk about the distance DC. The distance DC, the speed by which it is moving is 3, and it's 3, and the time that we need to calculate is 6. So it has covered a distance of 18 meters. From the total distance of 98 meters, it has so far covered the distance of 18 meters. Now let's calculate how much distance more the particle C and the particle D has to travel before they can collide. So let's talk about the collision of particles C and D. Collision of C and D. So the distance is going to be 98 minus 18, which will be 80 meters. They have to cover a distance of 80 meters. So this is the distance left between the particle D and the particle C. So we know that the distance that the particle D can travel will be the speed by which the particle d is traveling is the particle d is traveling with the speed of 5 meter per second. So 5 times t, and the distance that the particle c can travel further, it is going to be 3 times c, because it is still moving with the same speed. And we know that the total distance that they need to travel is 80 meters. So after time of 10 seconds they are going to collide. Find the time between the instant a is projected from the x and the instant that e reaches z. So basically we need to find out how far z does c and d collide. So let's find out how far from z does c and d collide. So we know that it's basically 3t plus 18. So 30 plus 18, that is 48 meter. This is the distance, and we know that the particle e, so the time taken, so the time taken by e to travel distance 48 meters. So how much time it is going to take? We know that the particle e is traveling with how much speed it is traveling? It is traveling with 33 meter per second. So time will be 48 divided by 3, which is going to be 16 seconds. So we need to find out the total time. So the total time is going to be the first lap, which is we already found at 6. The second lap, which is 10, we already found that, and the third lap, which is going to be 16. So 16, 66, 22 plus 10, 32 seconds. So this is how much the total time it is going to take. Let's move to the next question, the last question, that is question number 7. And yes, okay, let's question number 7 says that the two particles p and q of masses 2.5 kg and 0.5 kg are connected by a light inextensible string that passes over a smooth pulley fixed at the top, inclined at 30 degrees to the horizontal. Particle p is on the plane, and q hangs below the pulley such that the level of q is 2 meters below the level of p. Diagram: the particle p is at rest, is released from rest with the string taut and the slides down the plane. It is going down the plane. The plane is rough with a coefficient of friction, that is mu 0.2 meters. Find the acceleration. So we know that there is some component of weight. The weight is 25. Let's resolve the weight components. It is 20. This is going to be 30. Yes, this is going to be 25 cos 30, and this is going to be 25 sin 30. The normal reaction force is going to be upwards, that is R. The object is moving down the plane, so this is the forward force, and the backward force is going to be the resistance. Similarly for the particle, there will be the tension in the string as well, which will be T. There will be the tension in this string, that will be T, and there will be the weight of this particle, that is 5 Newton. So we are basically going to solve it for two equations over here. Since the object are, let's talk about particle P first. So for particle P, again forward, minus backward is equal to ma. The forward force is 25 sine 30 minus the backward force is the frictional force and it's the tension. The frictional force is mu r and the tension, and mass times the acceleration. The value of mass is known to us for the particle A, which is 2.5 kg, and the acceleration is the one that we need to find. We can find out the value of r. R will be equal to the downward component of the weight, which is thus 25 cos 30. 25 cos 30, and the value of mu is 0.2, so it will be 25 sine 30 minus 0.2 times 25 cos 30 minus t is equal to 2.5 a. So 25 sine 30, which will be 12.5 minus 0.2 into 25 into cos 30, which will be 4.330127 minus t. Let's take the t to the other side and let's bring the acceleration, because that's what we need to find out. So 12.5 minus this, it's going to be 8.1698 minus 2.5 a. That's the value of t. Now similarly we are going to make an equation for particle q, because that is also in motion, but it's going upward, so it will be t minus, the weight is 5, so t minus 5 is equals to ma. The mass of the particle q is 0.5 and the acceleration is unknown as a. So t will be equal to 0.5 a plus 5. We can put both the t equal to each other. So the values of t, it will be 0.16987 minus let me highlight it. It's 8.16987 minus 2.5a equals 0.5a plus 5. So minus 5, this is going to be 3.1698, which will be equal to 3a. So if I divide this by 3, the answer for the acceleration will be 1.06 meter per second square. This is the acceleration. Now let's move to the next part. Next part says that use an energy method to find the speed of the particle at the instant when they are at the same vertical height. So when they are at the same vertical height, for example, this is the horizontal surface, this is the angle 30 degrees. The particle P is moving on this path, and it is covering, for example, the distance as d, and for example this distance that the object Q is traveling at x. So when Q moves up, for example x meter, how far does P moves down? It's coming down, and this is the particle Q and this is the particle P. P is going down and the particle Q is moving up. So we can say that it will be sine 30 degree equals x divided by d So the value of x will be 1 by 2 times d, because sine 30 is 1 by 2. Now we know that particle P and Q will be at the same height. They will be at the same height when the vertical distance they have covered, or they can have traveled, they add up to 2 meters, because this is the total distance between the particle P and the particle Q. This is 2 meters. So we can say that the particle P and Q, d plus 1 by t, it has to be equal to 2. It is 1 by 2, yes. So it will be 1.5 d is equals to 2. The value of d will be 2 divided by 1.5, which is, the value of d will be 4.3 meters. So let's find out how much is the change in height. How much is the change in height? Change in height, it will be of basically the P particle. It will be 1 by 2 times d, which is 4 by 3, and that will be 2 by 3 meters. And it is going to be 2 by 3 meters down. It's coming down. Now it's very simple. We need to apply energy before and energy after, and equate them both, energy before and energy after of both the particles together as a system, and we will equate them equal to each other. So let's talk about the potential energy for P. It is 0 in the start. Kinetic energy of P, which will be 0, and work done by the driving force, it will also, of the particle P, it will also be 0. But similarly, potential energy for the particle Q, it will be mg and h. M is for the particle P. For the particle Q, sorry, we are talking about the particle Q. Yes, for the particle Q, mgh, it is going to be t times 4 by 3. It will be t multiplied by 4 by 3 joules. Kinetic energy of the particle Q, that is going to be 0, and the work done against resistance, work done at Q will also be, but the driving force of Q will also be 0, because it's not at the start. Now afterwards, let's talk about the potential energy at this afterwards of the particle P first. So afterwards, the particle P is going to be mgh, m is going to be 2, g is going to be 10, and the height that the particle P has traveled is minus 2 by 3, because it has come down. So 25 into 2 divided by 3, that is minus 50 by 3 joules. So that means, and then the kinetic energy of the particle P first, particle P kinetic energy will be half m, the mass is 2.5, the velocity is v square, and that's the one we need to figure out. That's what we need to find out. Then comes the work done. Work done against friction by the particle P. So it's basically mu r. Yes, it's going to be mu r. It's going to be mu r and t. It's mu r plus t into the distance covered. The distance covered covered is 4 by 3. The value of mu is known to us. Let's simplify it later. And now we also have a few more things for Q, which is potential energy for Q. Potential energy for the particle Q will be m, which is 0.5, 10 is the g, and the distance will be 4 by 3. So 5 into 4 by 3, it will be 20 by 3. Similarly, kinetic energy of the particle Q afterwards, it will be half, mass is 0.5. The speed is the one that we need to find out. It will be 1 by 4 v square. The work done against friction of the particle Q will be 0 because it is not in contact with any of the surface. It will be 0. So let's simplify. Let's put all of the before and after equal. Before just only have t times 4 by 3. So let's put that over here, 4 by 3t. But the after thing has a lot of things, which is minus 50 by 3 plus it's 2.5 divided by 2v square plus mu r. Mu is 0.2. The value of r is 25 cos 30. Mu r 25 cos 30. The plus the value of t, we already calculate the value of t. No, we haven't calculated the value of t, but we can calculate the value of t, which will be 0.5 into 1.06 plus 5. So 0.5 into 1.06 plus 5, which will be the value of the tension will be 5.53 Newton. So it will be 5.53 into 4 by 3 plus what more do we have, 20 by 3, and in the last we have 1 by 4 v square. So that's all what we have. Now let's simplify, and we already have the value for t. We have to substitute it here as well, 5.53. So it's 5.53 multiplied by 4 by 3, which will be 7.37. Let me write it in the fraction, so it's easy. That is 553 divided by 75 plus 50 by 3, and if I simplify, 0.2 into 25 into cos 30, that is 4 point. Let me write it same way, minus 50 by 3, 2.5 v square by 2 plus, if I simplify it all, it will be answer plus 5.53 into 4 by 3, that gives me 13.1468 plus 20 by 3 plus 1 by 4 v square. So if I arrange and simplify, it will be minus 50 by 3 plus 13.1468 plus 20 by 3, which is this. So it's 553 over 75 equals 3.14683 plus if I simplify them, it's 2.5 and it's 1.5 v square. So like terms together, so if I collect the like terms, 553 over 75, 3.14683, that makes it 4.2265 equals 1.5 v square divided by 1.5, that makes it 2.8176 v square, and if I take the square root, it's the value of v is 1.68 meter per second. So that was the speed of the particle at the instant when they are at the same vertical distance. So I hope you have understood all the questions. If there is any question that is there any ambiguity, please leave it in the comment section. I'll try my best to respond as early as possible, and wish you all the very best for your exam. Please do share the video with your friends so that it can help others too and help me grow my channel as well. Wish you all the best. Thank you. Allah Hafiz.